Hi, my name is Grace. I'm in 11th grade. I decided to do an experiment, and my experiment observed the sinking of paper and then a granite rock in carbonated and then a non-carbonated water. And my hypothesis going into this experiment was that it would take the paper longer to soak and the rock longer to sink in the carbonated water because I thought the carbon dioxide bubbles would cling to either object. So my first step in preparation for this experiment was doing some online research about the differences in carbonated and non-carbonated water, and the main differences I found was that the acidity levels differ and the presence of carbon dioxide gas differs. So according to Quench and Colligan, carbonation occurs when water is infused with carbon dioxide gas under pressure, and then bubbles of carbon dioxide gas release out of the carbonated liquid. So carbonated water is going to have the presence of carbon dioxide gas, and non-carbonated water will not. The World Health Organization says that most drinking, which would be the non-carbonated water, has a pH range of 6.5 to 8.5, and Banner Health says sparkling, which would be the carbonated water, has a pH range of 3 to 4. So non-carbonated water leans more into the neutral or the basic side of the pH scale, and then carbonated water leans more into the acidic side of the pH scale. And according to Pulp Paper Mill, all paper is porous, but composition determines porosity. So cellulose, which is the main structural component in plants, high cellulose papers are more porous, low cellulose papers are less porous. And then finally, Geology Science says granite is a hard, durable, igneous rock with a high density, low porosity, and acid resistance. The reason that I decided to test paper and granite rock is because the porosity differs so much, and I wanted to see the reactions in the carbonated and the non-carbonated water with something that was very porous and then something that was not porous at all. And next, I'm going to be demonstrating my experiment. I did 16.9 ounces of the carbonated and then the non-carbonated water, and I ran the experiment 6 times for each different thing. So for the paper, I did it 6 times in the carbonated water, non-carbonated water, and then I did the exact same thing for the rock. So this is the carbonated water and this is the non-carbonated water. And these papers are the exact same size. So I'm going to try to get them in at the same time and see which soaks faster. So this is the carbonated water. As you can see, this paper is soaking a lot quicker than this one, which is the non-carbonated water. So I'm going to be demonstrating the same exact thing that I previously demonstrated, but this time I'm going to be using the rock. So this is obviously the carbonated water, and then I have a stopwatch, and I'm going to compare the differences in sinking time of the carbonated and the non-carbonated water. So that was about 21 milliseconds, and this is the non-carbonated water. That was about 22 milliseconds. So for this particular testing, the differences did not vary much in the sinking time between the carbonated and the non-carbonated water, but they did vary when I ran the experiment 6 times. So I made graphs as visual representations of the data, and paper took longer in the carbonated water, and the rock took longer in the non-carbonated water. So this is the non-carbonated rocks versus milliseconds, and the mean sinking time was 21.8 milliseconds. And then for the rock in the carbonated water, the mean sinking time was 16.6 milliseconds. So it took longer in the non-carbonated water, and then going over to the paper, this is the non-carbonated water versus the paper, and the mean soak time was 23.6 seconds. And then for the carbonated, it was 29.6 seconds. So it took longer in the carbonated water. So in conclusion, my hypothesis was not proved to be wholly accurate because I said that it would take both the rock and the paper longer in the carbonated water, and it only took longer in the carbonated water for the paper to soak. So that was my experiment, and thank you very much.